I'll be going through an example of a one sample t-test for means. If you have not seen my setup on how to do a hypothesis test, you'll want to check out that video. It talks about phantoms and all the pieces for a hypothesis test. If you've seen that or you know how my hypothesis tests are organized, then you should know enough for this video. So here we go. A study of Pattonville students claims that students get an average of 7.5 hours of sleep at night. So that's 450 minutes. Mr. Hall suspects the average is lower than, I should say 7.5 hours. He collects a simple random sample of the amount of sleep in minutes that students get a night. The data that he sampled are the following. So I have a whole bunch of raw data here from my simple random sample of how many minutes students slept. Okay, so is there convincing statistical evidence that the average amount of sleep is lower than the study claims? So I've already written out this full problem to try and speed up a little bit of this video, but I'll explain kind of what I did in sequential order. So the first thing I did is I pulled out any information I felt was relevant and important. So there's the claim that the population average is 450 minutes. So I know mu is 450. My sample size n is just how many data points do I have? There is 13 there, so n is 13. Now, they're asking me to find statistical evidence that the average amount of sleep is lower than the study claims. So there is no indication of what sort of alpha we should use. So I was able to choose an alpha, and before I started this problem, I chose alpha to be 5% or 0.05 as my cutoff level there. So that's what I chose before I started this. Then I proceeded through phantoms, P-H-A-N-T-O-M-S. So my parameter of interest, just the focus of our problem here, is mu is the average amount of sleep for PHS students. That is the focus here. I then went to set up my null and alternative hypothesis. My null hypothesis is what we assume is happening. So the null is mu equals 450. The average amount of sleep is 450 minutes. What I'm trying to prove is my alternative. So I'm trying to prove that the average amount of sleep is lower than the study claims, so less than 450. That's what we're trying to prove. So then I went and looked at was the conditions in which I set up this study, are they all there so I can actually have some faith in my calculations and my answer here. So for hypothesis testing for means, the three conditions are, or assumptions are, independence 10% and check whether the sample size is large enough. So independence, the sample was an SRS, a simple random sample, so we're going to have independence there. Also helping out with independence, 10%. The sample is less than 10% of the population. So I surveyed 13 students. 13 students is definitely less than 10% of the entire population of all Pattonville High School students. That third assumption is the one that you'll definitely want to pay very, very close attention to. I checked whether my sample size was greater than or equal to 30. That's the first thing I look for. My sample size was not bigger or equal to 30, so it's not greater than or equal to 30. If it was, I'm good to go. That third assumption set, and we're ready to move on. My sample size was not large enough, so the next thing I did is I checked basically a graphical distribution of my sample. So I needed to check a box plot of my sample and just see what does my sample look like. So in order to do this, what I did is I did use my calculator to assist me here. I went to stat and then I went to edit. And I entered all of my raw data from the problem up above. So I typed in all of those number of minutes of sleep, the 413, the 480, the 324, etc. I filled in all those data points that you would have seen up above. Entered that in my calculator. Next thing I did is I did a second stat plot. I turned on my stat plot and I said, hey, show me the box and whisker plot that shows potential outliers. And that is what my box and whisker plot looked like for my sample. So when I look at my sample, this is the box and whisker plot. And what we're looking for is we want to make sure it looks roughly symmetric with no potential outliers. So this looks like an approximately normal distribution, which means I am good to go on this third assumption. If all three of these assumptions are true, then we know our sampling distribution is approximately normal. Therefore, I have a lot of confidence in the formula I'm going to use in calculating my t-score and thus my p-value, okay? If these assumptions fall apart, essentially your distribution, you don't know it's approximately normal. If it's not approximately normal, well, you can kind of throw out the whole idea of getting a t-score there. So because these assumptions are true, I'm able to move forward, and I know that, yes, I'm doing a one-sample t-test, so I identified that. I then went and did some calculating in my calculator here. So what I did is I went to stat over to tests. You would be looking for a one-sample t-test, but the way TI-84s label it is they just call it a t-test. I went in there, and you have two options. You can either do data or statistics. Since I have raw data, I went this route. If my problem would have told me what X bar and S is, my sample mean and my sample standard deviation, I would have gone the stats route there. So we're going the data route. It asks for, hey, what is mu? 450. Where's your data at? Mine's in list 1. We aren't dealing with frequency. I then have to enter which of the alternatives are you going to do. I was trying to argue less than. And then I did calculate, okay? When you do that, it is going to spit out what your alternative hypothesis is again. It is going to tell you what your t-score is. It is going to give you a p-value. It's going to give you X bar, S, and N. So I use all of this information to put together my formula for this hypothesis test. So it was t equals X bar, which was 415.69, minus mu, which was 450, divided by, and then I have a fraction of S divided by the square root of N. S is 72.46. N is 13. Now, if you calculate this t-score is negative 1.71. Now, anytime you do a t-score or anything with t, really, you're going to need degrees of freedom. So in a one-sample t-test, it's just n minus 1, or sample size minus 1, so I got a degrees of freedom of 12. My t-distribution is going to be centered at 0 with a standard deviation of 1. I labeled negative 1.71, put some notation on here, and my calculator told me the p-value is 0.0568. Before I move on to my final bit, I do want to talk about real quick, how can you look up a p-value if we didn't have the calculator tell it to us? So what we would be doing is you need to use your t-table. You would be going to 12 degrees of freedom, which is right here because we have degrees of freedom 12. You would look for negative 1.71, but this particular t-table is only going to show the positive t's, which is fine. We're going to look for a positive 1.71 in the degrees of freedom of 12. So if you look across, 1.71 is between these two values here. I know it's hard to see there, but that's 1.356 and that's 1.782. So my t-score is between these 2 points. So if you follow this up top, I know my p-value must be between 0.05 and 0.10. So you would know if you're doing this by paper, my t-score is in between these 2 points, so my p-value must be between these 2 points. And you can still make a conclusion and make a decision and state the context at the end knowing that. I use the calculator, which gives me an exact p-value of 0.0568, and that's going to allow me to move forward. Remember, what this p-value essentially means is, assuming this is true, you're essentially finding what is the probability that you could go out and get a sample that has an average of 415.69 or less. So it's basically finding what is the probability that you could go out and collect a sample that has this average or less. Well, if assuming this is true, I should be able to get a sample that I just got 5.68% of the time. So the question becomes, if something has a 5.68% chance of happening, and it just happened, is the probability of 5.68% something that we're comfortable with or uncomfortable with? And that's where that alpha comes in. Anything smaller than that alpha value, any probability smaller than this alpha value, that's where we're like, whoa, 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 something's not right here. Anything bigger than that alpha, that's when we're like, you know what, I think what you claim is true. We're kind of okay with your claim. Okay, so anything smaller than that alpha, we're like, nah, something's not right. And that something is, I don't believe your null hypothesis anymore. I think the alternative is what's actually going on. If our p-value is bigger than alpha, then we're like, well, I guess what you said was true. So since I had a p-value of 0.0568 and an alpha of 0.05, I'm essentially okay with this null hypothesis. We're like, I guess. So how we say that statistically is we say we failed to reject the null hypothesis. The reason being is our p-value of 0.0568 is not less than the alpha equals 0.05 level. So my p-value just is not small enough. We're failing to reject this idea, okay? We cannot throw out your assumption that mu is 450. So I'm failing to reject the null hypothesis, and then we're going to address our alternative. There is insufficient evidence, so I have not brought enough evidence to prove that this alternative is true. So I'm just going to say what the alternative is in words. Insufficient evidence to say the average amount of sleep is lower than 450 minutes. So I did not provide enough statistical evidence to say, yeah, the alternative hypothesis is what is going on here. So that was a hypothesis test. Yeah, quite lengthy. Make sure you have all these pieces along the way because they all serve a purpose. And again, that was a one sample t-test.